Hello, I'm Álvaro Calafell, and this is the third video about the harmonic problem solutions. In particular, this video shows an overview of the solutions for reactive power compensation equipment. In previous videos, we presented a guide for choosing the best solution for the harmonic problem and presented the solutions for electrical installations. The present video analyzes the solution for harmonic problems in reactive power compensation equipment. According to the 16th video, the harmonic problem solutions can be divided in those applied to installations and nonlinear loads and those applied to compensation equipment. In the present video, I will talk about the latter solutions. I will explain the resonance problem between capacitor banks and transformers or grid, and as well as the capacitor bank protections with the resonance mitigation solutions. An electrical installation with compensation equipment and nonlinear loads can be studied with the electrical circuit which follows, where we have a parallel set formed by the grid characterized by the short-circuit reactance, the capacitor bank, and the nonlinear load harmonic current source injecting harmonic currents. The frequency plot of the inductive and capacitive reactances of the grid and the capacitor bank is also shown below. According to the 12th video, to study the impact of harmonics on capacitors, we must determine the equivalent impedance observed from the nonlinear load. This equivalent impedance presents a parallel resonance at the frequency shown below. If the frequency matches with the frequency of the harmonic current injected by nonlinear loads, a dangerous amplification of the harmonic voltages may be produced. This amplification may lead to an overload of the capacitor bank, because the impedance value of the capacitor decreases with the harmonic frequencies. The following procedure is proposed to avoid the previous problem. First, the total harmonic distortion of the electrical installation at full load and without capacitors must be measured. If this total harmonic distortion is below 1.5%, the standard capacitor banks can be connected. If the total harmonic distortion is between 1.5 and 4%, oversized capacitor banks are recommended to avoid overloads. If the total harmonic distortion is between 4 and 6%, the use of detuned filters is recommended for compensation of reactive power and to reduce harmonics. If the total harmonic distortion is greater than 6%, the use of tuned filters is recommended. In the case that measuring the total harmonic distortion of the voltage is not possible, a similar criterion can be applied from the ratio between the apparent power consumed by the nonlinear loads and the nominal power of the transformer in the installation. The standard equipment contains capacitors with the same rated voltage as the grid. Oversized equipment contains oversized capacitors to avoid their overload. The tuned and tuned filters are equipment with a capacitor and an inductance tuned at a specific frequency. The former are tuned at 250 Hz, which allows to compensate reactive power without amplifying harmonics. The latter are tuned at the frequency of the harmonic, which must be eliminated. Both allow to compensate reactive powers as well as reducing harmonic voltages. It must be noted that the equivalent impedance observed from the nonlinear loads when the filters are connected becomes the following expression, which has a minimum value at the tuned frequency when the numerator is equal to 0. The impedance also has a peak value when the denominator is equal to 0. The minimum value of the equivalent impedance allows to reduce the harmonic voltage at the tuned frequency. To choose the standard and oversized capacitor banks, as well as the capacitor banks with the tuned filters, the rated voltage at frequency of the installation are required. The reactive power to be compensated is also required. For tuned filters, the current consumed by nonlinear loads at the tuned frequency is also required. As an example, we have the electrical installation in the figure, and we must decide which type of capacitor bank is required for the installation. The reactive power is calculated from the active power and the power factor. From the total harmonic distortion and the ratio between the apparent power consumed by the nonlinear loads and the nominal power of the transformer, it is concluded that a capacitor bank with stop-band filters at 250 Hz is required. This is due to a parallel resonance between the capacitor bank and the grid close to the 7th harmonic. We can also determine the fundamental current consumed by nonlinear loads and the harmonic current if the harmonic distortion is known. The following final recommendations should be taken into account when deciding whether capacitor banks are installed in polluted electrical installations. Capacitor banks with and without filters in electrical installations with harmonics must not be installed. Also, capacitor used with filters must be 10% oversized. And capacitor banks with several detuned and tuned filters must be connected in parallel.